Next up, we have James Munro, who's going to be talking about why a hedge fund built its own database technology and why they open sourced it, which I guess in any other industry, they'd be like, open sourcing it, that's a no-brainer. I don't think a lot of people don't quite understand the challenges that get in the way of people within financial services. So I'm really excited to hear how you managed to get over those obstacles. So I'll pass you over to James. Thank you.
Thank you. I'm quickly thinking about how I could add that to the talk. I definitely agreed with everything Alex was saying. I was a little distracted, I'm sorry, because I was trying to work out what the code was doing behind the text. Do you know what that was? No. Something on the command line. It was something. Anyway. Yeah, so I'm James Munro. I've worked for Man Group, a large alternative investment manager, for 13 years. And one of the things we've done, it's this crazy idea of building our own database and open sourcing it. So I'm going to talk through that. I'm going to give a bit of context first, because I think it's useful to understand why this is such a pressure point in a place like a hedge fund, that you really actually go to the depths of creating your own kind of database. So I'm going to try and give lots of context to that, and then I'll talk a bit about the open sourcing and some of the challenges now. So firstly, Man Group. So it's a bit like LSEG with group on the end, and inevitably we've got a group of things, and we do all sorts of things, so it's hard to summarize. But most of it is in alternative investment management. Most of it's kind of quant. So I spent most of the 13 years working with Man AHL, and I ran the tech team for 5, and they're like fully automatic, systematic, like alternative investment manager, so mostly hedge funds, and they basically take data in, do a whole bunch of research, and turn them into algo trading, and it's all completely like automated, so straight through data to trading. Numeric, also very quant, a bit more long only, and then we've got places like GLG, GPM, Varagon, FRM. Still a lot of quant going on, but discretionary, so a lot of quantamental, like data informing decisions. And all of that ends up being like a big problem of scale for us. We run at large size, and so we have to have a technology that supports it. So over $160 billion. I was putting this slide in, and I was thinking, actually, LSEG can beat a bunch of these numbers. But not AUM. But so we've got over $160 billion of assets under management. We have several hundred clients, mostly institutional, so things like pension funds. Lots and lots of funds and strategies that are kind of tailored for those clients, and all the kind of investment styles we run. And that ends up meaning, because these are like leveraged funds, that we're trading an awful amount, so $6 trillion roughly every year, depending on the vol of the markets. And we trade almost anything we can get our hands on, anything liquid. So it says 800 markets, but that's where you count like London Stock Exchange as a single market. So thousands and thousands of instruments. And many, many trades. So really what we've been doing over the last decade as we've been growing the business is like building the technology to support that. And a big part of that in the front office is a Python data science and mostly open source kind of ecosystem for all the quants and engineers. This is us on one little corner of the 4th floor in near Bank. And we run ArcticDB. So there's 12 of us, and we're taking a technology that's been developed over the last decade by as little as 2 engineers, but changing which engineers it was, and really trying to make it something for everybody. And we're turning it into a business. So it's not just open source, it's also a business. Abby on the right is here today if you want to talk to him as well. But it's mostly engineers, so we're doing lots of development, and we're working with others like Bloomberg to do that as well. So to the question, why build a database? So it made me think of this quote: "The distance between insanity and genius is measured only by success," by Bruce Furstein, which he helped on some of the Bond films. He's like an American author. And this is the Dali interpretation of that image. A slightly mad-looking person on the left, and a not much more sane person on the right. And a much younger version of Bruce in the middle. And so is it madness? Is it genius? Well, I think it's still to find out, but it's definitely working so far. So, and I guess the argument's like, actually, it's not that rare. So, a lot of the banks have their own, internal databases for the same kinds of reasons I'm going to talk about, and a lot of very proprietary technology. And other hedge funds have tried this as well. And what I would say is that actually a lot of the databases that are out there are born in a company somewhere to solve some problem, not generated by themselves in a vacuum. So actually I think it's not so much madness. And then I was trying to think about how to explain like what is the problem we're getting at. And if you take one step back from the eventual goal of providing alpha for our investors, then really it's the thing that's generating that is research productivity in the front office. And this is a plot from the American Economic Review in 2020, where they were looking at research productivity across sectors. And this plot in particular is from like semiconductor industry. And we all know the Moore's law that like the density of the chips doubled every 2 years. So it's roughly like 35% growth rate per year. And that though has been a kind of very clear story with like an exponential payoff for everybody in technology. But I guess the thing that's been talked about less is the cost of that payoff has been growing really steadily. So if it was one researcher back in 1970, it's now roughly 18 researchers to get that payoff. And it's not just true in the semiconductor industry, it's actually a problem across like the world and the sectors. And it's really true in quant research, in my opinion, as well. They didn't have a sector for that. But really, like this whole challenge, Man AHL started in 1987 with this algo trading, and they were one of the first. And the cost to get the same alpha now is just so much higher. And so that's where you've got this extreme pressure in the front office to combine the best data, the best people, and the best technology. And so, in that kind of background, we were looking for the best technology in 2011. This is like when I joined, at least. And Python wasn't actually that obvious a choice. So it was an emerging like data science, open language, had some decent open source tools. PyTorch didn't exist. TensorFlow didn't exist. Pandas first release was in 2008, but it definitely got more popular in the mid-teens. And that's when it really took off. So there was scikit-learn, SciPy, NumPy. And Python 2 was still the main choice. So Python 3 was still a pain at this point. This is a plot from Stack Overflow on language popularity. So really, as a quant hedge fund, you are typically talking about R, MATLAB, sometimes C++. These were the tools you went to. And so at this point, but we were seeing this, and we were seeing this massive like energy around this open source community, and we wanted to get involved, and that was part of it. And we thought this is a good bet for the future, and it's paid off. And I think that was a little bit of luck, not just wisdom. But that was one of the reasons we've got involved in all this. Another part of it, which is really about the productivity point, I wanted to sort of draw out by kind of thinking about a prototypical trading system from a systematic trader's point of view. So this is a very high level, I wish it was this simple, plot of how we do systematic trading. And typically you end up building like two data pipelines. So on one side, you'd have tick data coming in, very high frequency, low latency. And another, you're not going to do all that work to support tick data all the time, because there's a whole bunch of data you need, which is just like daily, maybe hourly, monthly, but mostly daily data coming in like files or downloads. And so you need a process for that. And you've normally got a much richer set of data coming in daily, but you've got like market prices coming in all the time. And so that's coming in. And then you're going to have some sort of model you're running, some sort of algorithm, some sort of machine learning model, statistical model that's going to decide what to do with it. It's not just about those trade ideas, though. It's also a whole bunch of portfolio optimization, risk optimization. And then you're sending your instructions to trading. And then you've got a whole bunch of analysis to do. So the point I'm trying to draw out here is that every stage in this, what's kind of happened, and this is not just true with us, but like in many quant hedge funds, is the data frames become like the model of moving data around and doing this kind of work, because it's a natural unit for data science, and that's not just true of quant. So those are the little table things. So you're pulling in tick data. You want some way to get that in batch mode to do your research, so you put it in a table. You want to do your alt data. Like, even if you're bringing in weather and like images, at the end of the day, one of the first things you're trying to do is turn it into some numbers in a table so you can actually use it. And then you're doing analytics or risk out the back end. And even if you're using like a heavily transactional database, like a SQL database or something, you're going to want to pull it out of that to do like serious analytics, because those SQL databases, one, they're in prod, but two, they might not scale to the kind of analytics you need to do. I think I'm all right on time because the others finished early. Okay, so So then, like one level below that, then what are you trying to achieve, and what were some of the pinch points that we were trying to solve for? And this is kind of the first part of the story. Why did we build a database? One was we were used to kind of like some heavily proprietary databases internally, and we tried a whole bunch, and we tried a whole bunch of open source as well at the time. And we saw that these were expensive to run, expensive to buy, and you needed lots of servers, and you couldn't move the data around quick enough. That was one aspect of it. Like the most successful research system we had at the time was for file-based data formats, and that's still kind of true today with like Parquet and things. And then we also saw that we were trying to build a system where we had hundreds of quants, and so rather than use like some sort of obscure dialect to interact with our database, we wanted a simple Python API. This is the skills we were hiring for, and we wanted all the quants to be able to use all the data as much as we could. So it wouldn't be like stuck in execution analytics for high frequency data. Everyone would be able to do this research, and everyone would be able to do the same kind of, take the same kind of methods and use them across daily data and tick data. So the other aspect of it, like almost one level below again, is like just the kind of data we're dealing with. So at one level it's tick data, so you might have billions of rows for a name. But then we also had use cases where we wanted extremely wide tables. So people were like, I really want to just generate these cross-sectional views. I might have daily data, but I want to do like 100,000 columns. And there's, without just storing that in a file, there's not really a database that supports that. And on the right there also, anyone at LSE will know, or LSEG now, this data's patchy, and, systems go offline. And the markets didn't exist in the past, or markets go away. Companies go away. So you need to be able to handle this kind of like less structure than you might want to. And overall normalization we saw as like a massive penalty on performance. So like having less normalized data in this kind of flexible way. And finally, we all know about the growth of data. This one I like because it's kind of got some detail in it. But this is from Eagle Alpha, who are a data distributor. So apologies, I've mentioned 2 competitors already. But to LSEG, but we work with lots of people. But there's lots of different data types, and this has been a massive expansion of alt data. And we've seen our data, like the amount of data we're storing just grow and grow like exponentially. And the types of data. So we just needed this flexibility, and we needed to, and one of the things of coming back to that point about productivity was like, if you're going to have twice as much data, if you're not going through that data twice as fast, then your productivity is already decreased. So if you've got twice as much data than you had 2 years ago, you need to be going through it twice as fast just to maintain your productivity compared to the alpha you're generating. I've got a summary, but I'm not going to try and go through them. Hopefully you remember some of the points I've made. But I'm going to try and spend a bit more time on the open source side of that. So one of the things was we did move to Python, obviously, and so it really wanted a Python first system, and it was really performant for that. And there's the second from the bottom is the point that it wasn't just about having something that is really easy to use across those hundreds of users, but that they could share data in it. So something that almost like feels like OneDrive does today. It's very extremely easy to share just with the name of the thing. Or work with it personally, so reading and writing, treating it as a personal database. So the story is that we had a first version of this, actually purely in Python, backed by Mongo, which we open sourced back in 2015, started development in 2012. And this was a good stepping stone for us. We did eventually move on beyond this, but this really paid off, and we announced the open sourcing of it backing with Mongo themselves. And just to give you some context, at that time, we thought this was cool, hundreds of millions of rows per second. And we could ingest 800 million ticks. So it's financial messages. It's like readers won't know what tick is, but maybe they didn't. But the 800 million financial messages per day. And that's what good meant in 2015. And that was really good. That really did scale for us. And we ended up running hundreds of Mongo servers at that kind of level. And storing a lot of data in it. But eventually that became a challenge for us. So we embarked upon a rewrite of this, which is the second part of kind of like our open source story. And actually this was open source and was reasonably well used across like our peers in the industry. So the second version of this is now called Arctic DB, so completely rewritten in C++. This Now there's no database at all, so it's connecting straight to storage, object stores either in the cloud or on-prem. And this we saw as a way to unlock like another level of scale and performance. We're no longer going to have to maintain these servers, and we're no longer going to be limited and having to sort of design for the peak load. But we're just going to be able to keep. Well, instead, our limits are only the limits of the storage devices that we've got, and all the database logic's done on the client. And this kind of serverless, so people talk about serverless, right? And this is kind of a new buzzword that's out there. Most of the time, they mean like the user doesn't have to worry, or the developer doesn't have to worry about the servers. But there's actually there's actually true serverless as well. And there are a few companies doing this, not just us, where there's no server, and in the sense of a traditional database server, but it's actually just storage and the client. So Pinecone, which is one of the vector DBs for AI, announced recently some of their changes to their architecture to kind of take advantage of this. And what you get is just like a much more of a scalable solution. For us, it's been like almost limitless. So this is just earlier this year. I just took a screenshot. Well, I took the CSV and put it in Excel. But the data from our storage device in London, and I didn't have a number for the number of rows per second, but this is well in excess of 1 billion rows per second sustained for our research users in London. And this is no database servers, just a storage device serving up to Python clients that are running our models, running our risk reports, all on our internal compute cluster, which is over 10,000 cores. So, and what sort of speed is this? This is about 40 gigabytes per second. So that's roughly 10 giggy network interfaces fully maxed out. And this is so it's just like another level of scale again. Why open source it? So I put some words up here, which is like the reasons people say why they open source things. But I'm going to talk about them a bit and try and give you a flavour of what it meant for us and what the challenges were. So I think at the time it was really about engaging with the community. So we saw this, as I said, we saw this emerging Python like open source community around data science. And we wanted to like extract the maximum talent out of that selfishly. But we wanted to support it. So we've been long-time supporters of PyData in London. And that kind of worked, actually. And, and we also were happy to share the source. I think we felt it wasn't a core part of IP. It wasn't something, as a hedge fund, we should compete over. Because eventually, in this stuff, right, there's always an open source version of it somewhere that solves the problem. So we wanted to be that open source version. I guess we wanted the recognition from our clients as well that we were kind of technology leaders. And I think all that kind of paid off. I think now, running ArcticDB, I'm benefiting from that organic adoption that happens. It's just so easy to try. Just install the Python package, get it going. There's no license to sign to try it. And the collaboration with other developers, that's happening. One thing I don't think is really true, people say it's somehow better on cost. It's not better on cost, in my opinion. This is grafting. I mean, for one thing, the quality does pay off. The quality of security, not because I'd like to say like we're good at it, but because you're forced to be good at it, because you have to put it out there, and you're just suddenly held to a higher bar. And it's not just about security either. It's about you're getting like bug reports from all over the world. So you kind of have to solve them. You can't just leave a stack of bug reports there, even if no one that you're actually talking to has had that bug. And you end up with an architecture which is separated out from your internal environment, which is just naturally better and ends up giving you a whole bunch of agility. But cost, I don't believe. So don't believe that one. I was going to mention, before I get to that, so what were the challenges of doing this? So one was the legal, and one quote I remember, and I think I can safely say this now, is that, because it was like back in 2015, was when we were talking to the lawyers about, we want to push this code out. And there was a conversation with the PMs, like, this is not IP, don't worry about it. And there's a conversation with the lawyers, like, this is fine, don't worry about it, we're just going to open source it. And there was a whole bunch of explaining what that actually meant. And then there was a whole bunch of checking that we were doing something sensible. But one quote I remember was, oh, this is great. And now you might be able to start using open source. And they were like, oh, he doesn't know. We're using a lot of open source. So like most of our code was open source. So There are legal hurdles, but it is definitely worth it, and I definitely think it's worked on a bunch of these axes. I did mention that other market data provider, so they are helping us develop it as well. And we're doing all right so far. We're up to like 40,000 on PyPy downloads a month on Python. And that was it, really. And I'd love a GitHub star. Thank you very much.